Okay, ladies and gentlemen, this is my first video of the new year. We've been trying to simplify radicals, so this is part 1. So notice what I have here is the square root of 48. So how do you simplify a square root? Well, first thing you always do is break it down. Do a factor tree, as we call it. So here I go. 48 is 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. So hopefully you've done factor trees before. But notice what I did was take this 48 here, and I just kept dividing it into smaller and smaller pieces. So what's the next step? Well, let's list what we have here. Notice we have a 2, we have a 3, we have a 2, we have a 2, and we have another 2. And these aren't just regular numbers. Remember, these are baby square roots. Each one is a baby square root. So now what? Well, the thing I'm going to be very direct here on is basically what you'll learn hopefully very soon is if I can pair up 2 baby square roots, I get a regular number, in this case 2. And if I pair up those 2 square root of 2's, I get another 2. Now remember, they're timesing each other, and I still have that square root of 3 left over, correct? So what's my final result? Well, 2 times 2 is 4 times the square root of 3. And so pause the video and think about it and make sure you understand what we just did by simplifying the square root of 48. So here's a second problem. Let's simplify the square root of 300. If you want to try it on your own first, go ahead and pause the video. If not, I'm going to start in a few seconds. Okay, so what was our first step again? We broke it down, right? Isn't 300, for example, 3 times 100? And of course 100 is 10 times 10. And 10 is 2 times 5. And this 10 is 2 times 5. What was the next thing we did? We listed them out, right? So let's see here. We have a 3. We have a 2. We have a 5. We have another 2. So we had a 5, then we had another 2, and of course we have another 5. And don't forget that these are baby square roots. And what was the next thing we did? To simplify, we pair up matching square roots. So notice square root of 3, there is nothing that matches it. However, we do have a square root of 2 that matches another square root of 2. So we do have a 2 out of that. Notice we also have a square root of 5, which matches another square root of 5. Times those together, you get a regular 5. So the 2 2's made a 2, the 2 5's made a 5, and of course we have that extra square root of 3 left over. Timesing that all together, 2 times 5 right here is 10 times the square root of 3. Okay, now pause the video again. Okay, so what happens though if we have a square root with just variables in it? Well, let's approach this very logically. Isn't x really just x times x? Isn't y to the 5th really y times, I'm just going to list them out, times y, times y, times y, times y? That's the definition of exponents, right? Well, remember that these x's and y's are really baby square roots again. Okay? And just like regular numbers, what would happen if I put these 2 square root of x's together? Well, I just get a regular x, wouldn't I? And what happens if I put those 2 y's together? I get a regular y. What happens if I put those two y's together? I get another y. And then finally, notice I have this extra square root of y that I can't match up, so it stays a radical square root of y. Timesing all of this together, notice I have an x, because there was no other x left over. I have y squared, because those two, y times y is y squared. And of course, I have the square root of y left over. And that is the simplified version of what we started with. So pause the video, and we're going to do one more where we put numbers and variables together. Okay, last one. So again, what was the first thing we always did? We broke things down. 40 is 5 times 8. 8 is 2 times 4. 4 is 2 times 2. The x3 is x times x times x. Let's just break it down by definition. And the y4 is y, 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 y. Now, without rewriting everything, let's just match them up. Because remember, all of these are baby square roots. So, does everybody agree that 5, first of all, does not match anything? Let's match up these two 2's. And isn't that going to make a regular 2? Notice we also have an extra square root of 2 here. And since that doesn't match any other 2, how about if we put the 2 and the 5 together and we get square root of 10? Okay, what's next? Well, can't we match up those two x's and get a regular x? Notice there's an extra x. Well, guess what? That goes inside the radical. Let's do the y's next. Notice we have two y's that make a y. We have another two y's that'll make another y. And if I times those together, wouldn't I get y squared? So here, ladies and gentlemen, is my simplified version of the original problem. So pause the video, and let me just remind you guys, the advantage of any video is, of course, you can always rewind it and or watch it again. This is definitely one video that you want to watch and practice several times. I'll see you in class next time. Until then, bye.